Today we're going to go over Tuesday's lesson, which should be today. You should be watching this on Tuesday. Lesson 37, chemical compounds and parallelograms. First we're going to do chemical compounds. This is more like a chemistry lesson than it is a math lesson, but there is math involved, so that's why it's a math lesson. Up here, you've probably heard of this before, H2O, which stands for water. That's the chemical name for water. This is a molecule, H2O, and it's broken into atoms. There's 2 hydrogen atoms and 1 oxygen atom in a water molecule. This is zinc nitrate, and it's 3 zinc atoms and 2 nitrate atoms, which makes zinc nitrate. So it's 3 zinc atoms, 2 nitrogen atoms. Every kind of atom, so this is made up of zinc and nitrogen. Each of those atoms has a specific molecular atomic weight. So that's what this is. So let's look at how you're going to use an example to do this. Here's our water molecule, H2O. They're going to give you in the problems what each atom weighs. Oxygen weighs 16 grams. Hydrogen weighs 1 gram. And they're going to give you a molecular weight. My husband's filming me and he looks really funny, that's why I'm laughing. If you have 3,600 grams of water, that's your molecular weight. They want us to find out what is the weight of oxygen. So we have the weight of the whole molecule. We need to find out what the weight of just one oxygen would be if it was 3,600, how much the oxygen would weigh. So we have hydrogen, there's 2 hydrogen atoms. So we have to take the weight of the hydrogen atom, which is 1, times 2. So what we're going to do is we're going to set up a little ratio chart here, just like what we've done in the past. So we have our hydrogen atom, we have 2 of them. So I'm going to take 2 times our hydrogen. This is where it's going to tell you how much each atom weighs. So our hydrogen weighs 1 gram. So to figure out the weight of a hydrogen, how much hydrogen is in 1 molecule, I need to take it times 1. 2 times 1. And so we're going to find out that the hydrogen weighs 2 grams. Then we have to figure out the oxygen. There's only 1 oxygen. If you look back here in the molecular formula, there's only 1 oxygen, but it weighs 16 grams. So we have to take it times 16. And we're going to get 16 grams. So the total weight of an H2O is 18 grams. But they asked us, they want to know if there's 3,600 grams of water. So we put that under the total column. If there was 3,600 grams of water, how much would the oxygen have to weigh? So we don't know what that is, so we'll call that O. We don't know how much oxygen. They're not asking for the hydrogen, so we don't really care about this. So I'm just going to cross that out. Now, if you notice, what we made is a proportion like what we've done many times before. I'm just going to call this OX, so it doesn't look like a 0. So we can set up a ratio with these numbers once you fill in your chart. It's 16 over 18 equals our oxygen over 3,600. And then we would just cross multiply, and we would get 3,600 times 16 equals 180x. Divide both sides by 180. And we would get that our oxygen, I lost my O, our oxygen, let me just cross that out, oops, should be 18OX. Getting looking like a 0. Let me just erase that. We're going to get our oxygen equals 3,200 grams, just for our oxygen. Be careful with your O's because they can look like zeros. Let's look, if you don't understand that one, we're going to try another one that's very similar. So let's